Hi, welcome to this demo presentation for the AWS NVIDIA Environmental Hackathon. My name is Syed Rizvi. To address this hackathon's challenge of detecting anomalies in data from Amazon Seattle spheres, I chose to stick with the autoencoder approach for my machine learning model. To create the model, I used Python and PyTorch alongside several other utility libraries, all on a Jupyter notebook in a SageMaker P3 instance. In order to create reconstructions of data for anomaly detection, I decided to build my model using 7 neural layers with sizes of 2,112, narrowing down to 211 at the bottleneck, and then 3 more layers fanning back out to the original input size. The model was trained for 15 epochs on training data from the North Conservatory, with batches of 20 samples passing through the model before gradient calculation. After the model was trained to reconstruct a day of sensor readings, the test data with injected anomalies was run through the model and the loss values for each sample was computed and sent to an evaluation method, which you see here on the right. This evaluation method takes in the loss values for each test sample and labels the sample anomalous if the average mean absolute error for that sample is too high, or if at least a third of sensor readings from any sensor in the sample differ from the model reconstruction values significantly. The model returns a list of suspected anomalous sample indices, along with the corresponding list of indices within the samples of where the model suspects the anomaly starts. A value of -1 in the second list indicates that the model does not know where the anomaly starts. And here you see some plots of samples that the model labeled as anomalous. You can see that the plots, there are a few areas of bad sensor readings, which the model picks up on. Due to the evaluation method, the model will perform well on these sort of continued anomalous values. However, it will have a harder time picking out a single bad reading from a day of data. And that is the end. Thank you for watching this presentation.